Now we're going to check out the Filadry. The Filadry is marketed as what I would call a filament conditioner. It's mainly focused on drying out the filament and heating it up in flight before you start to print with it. So they're trying to resolve any issues with the filament with moisture that you might have to get you a better print. We got to see the Filadry at MRF, and if you were at MRF or have seen any of the videos, then you've seen this. This is the display they had at MRF. They actually had a submerged roll of filament that was being pulled through the Filadry and then to a printer sitting on top of the tank. They also have some video out there of the Filadry in action that I'll leave the link to in the description. Now my buddy Walter over at Kuntry 3D actually snagged this Filadry from MRF, and he was going to give it a test, but he thought he'd ship it to me so I could test it first. Much appreciated, Walter. And our friends over at IC3D thought this was a great idea, so they provided the filament for this testing. And it's not just PLA and PETG filament, this is filament that came off the same machine back to back. So the ages of this filament is as close to the same thing as possible, both spools. And even though it's brand new filament, I'm going to go ahead and dry all these spools overnight just to make sure they're as pristine as possible before we do the test. Now, while I unbox this and get this stuff drying, let's take a look at the Filadry up close. So let me show you what's going on here. The Filadry is made to be used in flight. So you have a spool of filament on one side, a printer on the other, and the filament runs from the top to the bottom or vice versa and conditions the filament as you print with it. It's a pretty simple box. There's a fan on the front, there's a fan down here on the side, a power switch, and a DC jack. It does come with the adapter, and these are 3D printed parts in here. So the PLA's in the dryer. I will follow up and dry the PETG. All 4 spools will have about the same amount of dry time. Of course, the PETG will be at a little higher temp. But while we wait for things to dry, I thought it'd be fun to test some nylon. Now this spool of nylon has been sitting down here for 3 weeks in open air in about 50% humidity. So more than enough time for it to have picked up a little bit of moisture. So I thought we'd grab the Mark III and run a couple of tests. One without the Filadry and one with. This could be interesting. If you listen really close, you can hear the vapor escaping from the filament. So our first nylon benchy didn't come out so good, but there's a couple reasons for that. One, it's nylon. It's not going to make the best benchy anyway. But 2, it's really, really wet. There's a lot of moisture in this material. Just for reference, this is a nylon benchy I did a long time ago. This is the best nylon benchy I've ever been able to get. It came out okay, but again, it's still nylon. It's going to have a few problems with overhangs and being able to cool it quick enough to get it to turn out well. And to give you an idea of the condition of this filament, of how much moisture it's actually collected, I'm going to feed some through manually. Just take a look. If you look real close in this area over here, you can see the vapor escaping as it's extruded. Now let's set up the Filadry with this same nylon and print a benchy. First thing, let's just go ahead and thread it through. I'm going to try to thread it from the top to the bottom. That wasn't working so well, so I decided to go from the bottom to the top. Unless your filament is as straight as an arrow, probably rigid like PLA, this is going to be a nightmare to feed through here because there's no guide running down through here. It just appears to be holes from end to end. So if it curves at all, it gets lost somewhere inside this box. But I managed to get it through, so let's go on with testing. So before we start the test, I'm going to turn it on and let it heat up for about 30 minutes. I want to give it the best chance of drying out this filament that we can. So the Filadry should be nice and heated up by now. I am going to mark where the filament was, the filament that has already been dried, and then I'm going to feed this into the printer. I'm going to mark it again so we know where the slow movement of the filament should start as the print starts. So we've got the Filadry all set up. We've started the print. I'm going to mark the filament right here. So that way we'll know everything after this has been pulled through the Filadry nice and slow, so it's given it a chance to dry it out. Let's see how it goes. So it's currently working on filament that wasn't in the Filadry very long, the stuff that I pulled out just to load the printer after that initial piece that had been in there for about 30 minutes, and you can definitely still hear the popping where the filament has moisture in it. So here's our mark where we mark the filament on the other side of the Filadry. So everything after this should have gone through the Filadry nice and slow as the machine printed. So now we'll just let it go. Everything but about the bottom 15% should have been dried thoroughly through the Filadry. So let's see how it does. So we're still printing the Filadry nylon benchy. It's going pretty well, but I do hear some popping still. So the filament might be drier, but it's not completely dry. All right, let's have a look and see how we did. The first thing I noticed is there's a nice line where the Sharpie mark was, so it added a little bit of black from where the Filadry wasn't and where the Filadry was. So that's kind of nice. So we have our non-Filadry benchy and we have our Filadry benchy. From what I can tell between the two, there's no difference at all. I did give both these benchies a really hard look all over, and I really can't find anything different from Filadry to non-Filadry. This is the Filadry benchy. You can see where this filament wouldn't have been in the dryer very long, and this filament was pulled through as it was printing. There's really no difference in between those two sides. And just for comparison, here's the non-Filadry benchy. Almost identical. And just to give you an idea of how wet this filament is one more time, this is filament that has been through the Filadry. I'm just going to extrude some manually. You can see that vapor just roll off of it. The PETG and PLA have been thoroughly dried. I am drying out the nylon right now because I'd like to do one more test print. But now we need some baseline prints on this filament. So let's get to printing. So the base prints are done, and I did take one more attempt at a nylon benchy after I dried that nylon for about 48 hours, and it came out great. Let's see how we did. Here's our baseline PLA benchy from spool 1. A respectable print, not the best benchy I've ever seen, but not too bad. And here's our baseline benchy from PLA spool 2. Pretty much the same as spool 1, the spools are pretty consistent. That's what we're going for here. Baseline PET benchy from spool 1, it's a bit stringy. I probably need to tune my temperature a little bit, but we're going for consistency in filament here, not for quality of print. And baseline PET benchy spool 2. Again, pretty much the same as spool 1, we're just going for consistency from spool to spool. And I take back everything about the nylon benchy that I spoke about before. This is now my best nylon benchy. After I got that filament super dry, it came out really clean for nylon. So we've seen the baseline prints without the Filadry with our brand new filament that's been dried out. But now for the part that I've been dreading. I'm going to take these 4 brand new spools of filament and I'm going to put them in this bucket and I'm going to completely submerge them in water for 1 week. Then we're going to run our tests again with the Filadry and without the Filadry and see what changed about this filament. Here we go. I'll see you in a week, Filament. Well, it's been a week. Whose idea was this anyway? So all the plastic is thoroughly soaked. Now I'm going to get it set up on some spool holders so I can print it without getting water everywhere. So I've got 2 spools of PLA and PETG. Both came off the same machine back to back, so they're really close to the same thing, and everything's been soaked in water for 7 days. On spool 1 of both materials, I'm going to use this highly technical method of this sponge and a binder clip to dry it out. And on spool 2, I'm going to use the Filadry. The Filadry will be used as the filament's being printed, nice and slow, pulled through the machine. So let's get set up to do the PLA first. We'll go with spool 1 and the sponge. Alright, we're ready to start the first test. PLA, no Filadry. The non-Filadry benchy is done on spool 1. Now we'll set up spool 2 with the Filadry. The Filadry has been running for over an hour to get it warmed up before I start this print. So this isn't good. Just a couple layers into my print, I noticed the filament was getting a little thin. Well, as it's running through the Filadry, it's so hot, it's actually melting the PLA and making it stretch. Check out how thin it is right here as it's melted it. Also, if you pull it out of the Filadry, it's rubbery. It's completely melted. So I found that it's almost impossible to feed the filament from the top down. There's some sort of mechanism inside the Filadry that won't allow you to do that. So I'm back to going from the bottom up, but I put it in some boxes to try to give it a better trajectory towards the printer to see if that helps any. We'll try again. So we almost made it through a full PLA benchy that time, but it's still stretching the filament out. So if there's any resistance on the spool at all, even slight, it's going to get hung up in the Filadry, stay in there too long, and start melting the plastic. Then the printer starts to pull on it, and it just stretches it out rather than pulling it through. So if there's any benefits from the Filadry, it might be causing the diameter of your filament to change, which isn't going to help you at all. Let's go ahead and look at the comparison side by side from the results that we have. So just for a refresher, here's our brand new dried out filament benchy, our base test. And here's 7 days in the water with our sponge attached. It definitely did degrade the filament some. It is stringier, but not that much. And here's our almost complete benchy, about the same amount of stringing as with the sponge. And here's the sponge benchy and the Filadry benchy. The only difference is the sponge benchy actually completed. So the water did degrade the PLA a bit. You could definitely see a little more stringing, and the ends of the spools were pretty brittle. But after you snapped about 3 or 4 inches off, it was fine again. So really the only difference in between the Filadry and the non-Filadry is the Filadry's melting the plastic on the way through. We can put that PLA in a dryer and it'll be good as new in a couple of hours. But let's move on with testing to PETG. PETG is a lot more prone to gathering water, so I'm curious to see what it's like before and after the Filadry. Maybe it'll work a little better because PETG is a lot higher temp. So let's try it out. We'll start with just the sponge, just like with the PLA prints. Non-Filadry PETG benchy is done, and let me tell you, it's looking stellar. But we'll check that out in a minute. Now let's get the Filadry set up on spool 2 and run another one. And the Filadry PET benchy is done. Now let's compare those benchies and clean up some of this stuff so we have a little more room. And as just a reminder, here's the baseline PET benchy after it's been dried. It's stringy, but doesn't look too bad. And here's a look at the non-Filadry benchy after it's been soaked in water for a week. Not only is it super stringy, you can see all the pits in the print where the moisture escaped. Not looking very good. And here's the same thing after it had been ran through the Filadry. Pretty much the same results. Super stringy, a whole lot of pitting, just really wet filament. And the Filadry didn't seem to be hot enough to have the same effect on the PETG as it did the PLA. It didn't want to stretch it as it pulled it out of the Filadry. So that was good. But all the tests that I ran on PETG, PLA, every test before and after with the Filadry, all the prints seem to be identical. I can't tell that the Filadry is actually doing anything, except in the case of PLA, and it's melting the filament. At $140, I would definitely want to see some vendor before and after pictures of what the Filadry can do before I even considered purchasing it. Again, a big thanks to Walter over at Kuntry 3D for supplying the Filadry. Definitely check out his YouTube channel, and all his information will be in the description below. And to IC3D for supplying all the filament for this testing. I hope you found this video helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below. And as always, thanks for watching.